dear students, Standard 11, chapter number 4, Laws of Motion. So in previous chapter we studied what is motion, and now we have to study about laws of motion. So here first we have to discuss Aristotle's fallacy, right? Aristotle suggested this thing: an external force is required to keep a body in motion. So Aristotle suggested this particular law of motion just with day-to-day observations. But it was false, right? Later it was proved, and therefore it is known as Aristotle's fallacy. After Aristotle's law of motion, scientist Galileo took some precise observations related to the motion of the body. So which type of observations he took, and with the help of those observations he represented the law of inertia. So how he performed experiment? So in his experiment he took two inclined plane as shown in the figure, and one spherical body, when released from the top of the inclined plane, he observed this thing: when the body is moving in downward direction, it accelerates. It implies that its velocity is continuously increasing one. Then after, on the opposite inclined plane, when it moves in upward direction, then it retards, means its velocity continuously decreases. Now here in between these two, motion on the horizontal plane can be treated as an intermediate situation. So with this type of precise observations, he suggested this thing: if horizontal plane is frictionless, then there is no acceleration or retardation of the moving body. It implies that if the body is moving on smooth surfaced, frictionless horizontal surface, then it continues its motion with constant velocity. Then after, he performed second experiment. In second experiment, he took this type of double inclined plane, and in the middle part of it, it was horizontal. So here he observed this thing: from left hand side, if the spherical body is released, then it accelerates, and if the horizontal part, that is the smooth one, if we consider it frictionless, then almost it moves with constant velocity. When it moves on other side, it retards, but the height attained by the body on other side, that is almost the same one, maybe slight less than that, but almost the same one. Then in second experiment, he took the same double inclined plane, but on other side, means on right hand side, the inclination was less. Okay, so again when the experiment was performed, he observed this thing: the spherical body attains the same height on the other side, but to attain the same height, it travels more distance, right? And then after, third experiment was performed with the help of single inclined plane, right? And from upper side, when the spherical body is released, then it accelerates, and when on this horizontal smooth surfaced motion is there, at that time it moves with constant velocity. So with the help of this type of precise observations, he suggested law of inertia. Law of inertia says this thing: if the net external force acting on the body is zero, then the stationary object or stationary body that remains stationary, or we can say steady object that remains steady, and the body which one is in motion continue its motion with uniform velocity, or we can say with constant velocity, right? And this is known as law of inertia, right? Or we can say inertia is nothing but the resistance to change. It implies that body itself opposes any type of change in its state of motion. If body is steady, then it wants to remain in the steady state. If body is in motion, then it moves with uniform velocity and it continue this motion till the net external force is not acting. So this particular characteristic of the body or property of the body, that is called inertia, and that is nothing but resistance in change. Clear to all of you?